All right, let's start with a brand new topic, parametric equations. So let me start with an example of what a parametric equation could be. So a parametric equation will have two equations, an x equation and a y equation, and both x and y will involve a parameter t. So x will be t squared in this example, y will be 2t minus 1, and t is going to take values in between -1 and 2. So if you haven't seen what this notation is, this is notation t is an element in the set of numbers in between -1 and 2. This is just a fancy way of writing down that t is in between -1 and 2. So parametric equations are two equations, an x equation and a y equation, that depend on a parameter t. The values of t can be in this range. These give you different xy coordinates in the xy plane. So if I plug in different values for t, I get different xy coordinates. So for example, if I plug in t equals -1, so if in this example I have values of t, I have values of x and y. If t is -1, then x is 1. So I just look over here, -1 squared is 1. And y would be -3. If t is 0, then x would be 0, and y would be -1. And then t could be 1, 2, or any number in between. They don't have to be whole numbers. You know, any number like 1.1 or anything would work. But if I plug in 1, I get 1 for x and 1 for y. And if I plug in 2, I get 4 for x, and I guess I get 3 for y. So I have different t values, which give me different x and different y values. I can plot those values in the plane. So if t is -1, I'm here at x equals 1 and y is -3. So that's the value I'm at when t is -1. If t is 0, I'm at x equals 0, y equals -1. That's t equals 0. If I'm at t equals 1, I'm at 1, 1. There's t equals 1. And then if I'm at t equals 2, I'm at x equals 4 and y equals 3. So I'm up here. I didn't plug in values of t in between -1 and 0, but if you did, you get more points. In fact, you'd get all the points that lie on a curve that looks like this. So this curve is my parametric equation. Now, these are a little bit different than functions. So there are differences here that I want to highlight. So how is this different? How is a parametric equation different than the graph of a function y equals f of x? Well, there are a few main differences. Number one, a parametric equation has a start and an end. So the values of t in this example begin at t equals -1 and end at t equals 2. So in my curve, I have a starting value and an end value. So this is my start, and this is my end. So they have a start and an end. I guess the next key difference is that they may not pass the vertical line test. So you know, to be the graph of a function, it must pass the vertical line test, meaning the graph can only intersect a vertical line at most one time. This is not the graph of a function. It doesn't pass the vertical line test. There's also a direction. You may have noticed I put like an arrow here. There is a direction that this curve is being traced out. So as t goes from -1 to 2, I'm drawing the curve up. That's the direction I'm heading. The graph of a function doesn't have a direction necessarily. And then this one's more subtle, but there's also a speed. There's also a speed. In this example, I go from t equals -1 to 0. I go this distance in 1 unit of t. So if t is time, for example, which is a great example to keep in mind when you do these, imagine t is time. It takes me 1 second to go in between these 2 points. It takes me 1 second to go in between these 2 points. And it takes me 1 second to go in between these 2 points, which is a longer distance. So I went kind of faster along this part of the curve than I did at other parts of the curve. So there's a speed that's kind of inherent in a parametric equation. So for these reasons, they have a start and end point. They may not pass a vertical line test. They could loop around. They can draw all kinds of crazy patterns. They have a direction and a speed. This is why parametric equations are the best tool to track moving objects. So if you're shooting a rocket into space, the path of that rocket is best described by a parametric equation. If you're tracking some particle in physics, use a parametric equation. If you're trying to design a 3D printer head, the pattern that the 3D printer head moves should be described with a parametric equation. So parametric equations are the tool to use when you're tracking a moving object. So I'd like to do another example to finish this video. This is a simple but very important example. Let's do x is equal to cosine t. Let's do y equals sine t. And no parametric equation is complete unless I tell you the range of acceptable values of t. So I'm going to say t is any number in between 0 and 2 pi. Okay, it turns out that the underlying shape of this example is a circle. So the shape is a circle. How do I know that? Well, if I take x squared plus y squared, I look at my parametric equations, that tells me that cosine t squared plus sine t squared, and using the only trig identity that you really know, sine squared plus cosine squared is equal to 1, I get 1. So x squared plus y squared is equal to 1. It's well known that that's the equation of a circle of radius 1. But a parametric equation is so much more than just a basic shape. It has a start value, it has an end value, it may not pass a vertical line test, it has a direction and a speed. So let me plot this parametric equation. So the underlying shape is indeed a circle. I agree with that. So let me draw a circle here. But there's a start point, there's an end point, there's a direction, there's a speed. So it's not enough to tell me that this parametric equation describes a circle. That's not complete information. It doesn't fully describe what's going on. So here is the full description. At t equals 0, I'm right here. So that's t equals 0. If I plug in pi over 2, I'm up at this value. The circle is traversed counterclockwise. So I'm drawing the circle as values of t change counterclockwise. So I'm going this way, and I'm going around exactly one complete turn. So as t goes from 0 to 2 pi, I'm going around the circle exactly once, and then stopping at the same value that I began at. So my start and end point is the same. I'm traversing the circle counterclockwise exactly once. So that's a better description of what these parametric equations tell you. Now, you could think of parametric equations as the knobs on an Etch-a-Sketch. On an Etch-a-Sketch, the toy, there's one knob that controls the vertical movement and one knob that controls the horizontal movement. That's kind of what these parametric equations are doing. The x is telling you a horizontal movement. Where should I be on the x-axis? If I move left or right, how far should I be? Well, that's the x-axis, and the y-axis is how vertical should I be. So it's kind of like drawing on an Etch-a-Sketch where I'm controlling the x-coordinate and the y-coordinate separately. Okay,